Hi students, I am Kotre sir from Chikkodi, and in today's class I would like to give you the theoretical ideas regarding the linear equations in two variables. This is the third chapter as per your 10th CBSE syllabus is concerned. Now let us have a look at the theoretical concept of this topic. Now observe here. The chapter name is pair of linear equations in two variables. Pair of linear equations. So first of all, let us try to understand what is the meaning of linear equation in two variable before moving to pair here. See, an equation of the form. See, if you take into consideration the equation of the form ax plus by plus c is equal to 0, where a, b, c are real numbers, where a, b, c are belonging to reals. This is a standard form of the linear equation. Ax plus by plus c is equal to 0 is considered to be the linear equation in how many variables? Two variables. See, observe carefully. What are the variables? See, x is, this is one variable. This is a variable here. And then y, this is another variable. So, two variables are there. Two variables are there. It is called linear equation in two variable because linear, the highest power of both x and y, both the variables will be one only. And there is one more reason to say that it is linear. If you plot the graph of this equation, ax plus by plus c is equal to 0, here the graph seems to be a straight line here. Ax plus by plus c is equal to 0. Here it is a straight line. This is a straight line. It means it is linear. This is also another reason why we call this as a linear equation. So this is what the meaning of the linear equation. An equation of the form ax plus by plus c is equal to 0 is called a linear equation. See some examples. See 2x minus 3y plus 2 is equal to 0. This is a linear equation in two variables. X is one variable, y is another variable here. Now let me write 3p plus 8q minus 1 is equal to 0. Here p is one variable and q is another variable. So this is a linear equation in two variable. Linear equation in two variable. Now let me make it clarify. What is the solution? What is the solution of a linear equation? Solution of a linear equation. What is the solution of a linear equation? See, if you take into consideration a linear equation, ax plus by plus c is equal to 0. If you want to say x is equal to alpha and y is equal to beta, be the solutions. X equal to alpha and y equal to beta. These are nothing but what here? These are the solutions. These are the solutions of which equation? Ax plus by plus c is equal to 0. X equal to alpha and y is equal to beta are said to be solutions. Then this condition must satisfy. A alpha plus b beta plus c must be equal to 0. If you want to mention these two values alpha and beta to be the solution of this equation, then both alpha and beta must satisfy the equation ax plus by plus c is equal to 0. Now let us understand this with the help of an example. Now let me take into consideration this example here I would like to take. Let us check whether x is equal to 3. Check x equal to 3 and y equal to 2 be the solutions of. Check whether these two x equal to 3 y equal to 2 is a solution of 3x minus 5y is equal to 9. 5x minus 3y is equal to 9. Solution of 5x minus 3y is equal to 9. Now let us check whether these two, here this is alpha in this case, this is beta in this case. When do we say that alpha and beta are the solutions? Those must satisfy the equation. Now in order to check whether x equal to 3 and y equal to 2 are the solutions or not, you have to simply substitute x equal to 3 in place of x, y equal to 2 in place of y. So that's why I would like to take only LHS part, that is what 5x minus 3y is there here. Make the substitution now. 5 into x value is how much? 3, and then minus 3 into y value is how much here? 2. So 5 3s are 15, 3 2s are 6. So 15 minus 6, this leads to, 15 minus 6 is 9, not 11. So this is nothing but 9 here. So this is our RHS here. See, exactly same. So LHS is equal to what you can say? LHS is equal to RHS here. So this confirms that x equal to 3, y equal to 2 is the solution of the equation 5x minus 3y equal to 9. So you remember, if you want to say x is equal to something, y equal to something, to be the solutions of the given linear equation, then both the values of x and y, what you have taken, those must satisfy the given linear equation. Then only those two values constitute the solution for that. So this idea you remember. And further, in the next context, I would like to discuss mainly regarding the simultaneous or the pair of linear equations in two variables, or simultaneous linear equations in two variables. We may take in this manner also: simultaneous, the system of simultaneous linear equations in two variables. Now let us have a look at the next aspect here. See, in the next part of discussion, I would like to take into consideration simultaneous. Pair means simultaneous. Pair of, you may include this word, simultaneous. Pair of simultaneous linear equations in two variables. See, you have to take into account, you have to take into consideration two linear equations at a time. See the equations a1x plus b1y plus c1 equal to 0. This is one linear equation. And then another equation I would like to take like this: a2x plus b2y plus c2 equal to 0. This is another linear equation. So these two linear equations put together constitute the pair of linear equations in two variables, where a1 b1 c1 and a2 b2 c2 are real numbers. But unless one condition is there, these are said to be, this system is said to be a system of linear equations. This is said to be a system of simultaneous linear equations in two variables, only when they have a common solution. They must possess a common solution. This must satisfy it. That means there should exist common solution. Means what? There should exist some x is equal to say alpha and y is equal to beta, which satisfies both the equations. Then only what we can say, this is going to form a system of simultaneous equations in two variables. Now let us have a look at one question. I would like to take into consideration an example. Let me take into consideration this example: x plus y is equal to 10. Very simple simultaneous equation I would like to take. X plus y equal to 10 and x minus y is equal to 2 I would like to take. This is going to form a simultaneous system of equations. Here, if you take into consideration x is equal to 6 and y is equal to 4, you take. When you take x is equal to 6 and y is equal to 4, you see x plus y, that is nothing but 6 plus 4 is equal to 10. So what you are getting? 10 is equal to 10 you are getting. So this set of values x equal to 6 and y equal to 4 satisfies the first equation. Now let us check for the second equation. A second equation is given by what? X minus y equal to 2. X is 6, y is 4. So 6 minus 4 is equal to 2. So 2 is equal to 2 you are getting. LHS is equal to RHS. So second equation is also satisfied. So x equal to 6 and 4. 6 and 4. 6 and 4. These two are satisfying this equation and as well as they are satisfying the second equation. So x is equal to 6 and 4. These are nothing but what? These are the common solutions. This is what the speciality of the system of linear equations in two variables. Simultaneous. Why do we call it as simultaneous? Simultaneously they are having common solution. That is what the main theme of the simultaneous linear equations. So in the next part of the discussion, if we represent geometrically the simultaneous linear equations, how they behave, what geometrical view we find as far as simultaneous linear equations is concerned, let us have a look at that. Now see students, before moving to the geometrical view of the simultaneous linear equations, one more important information I would like to give regarding the consistency and inconsistency. If you take into consideration these two equations, a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 is equal to 0. So this system of equations put together is said to be consistent. This is said to be consistent system only when this system has if it has at least one solution. There should be at least one solution. Then this system is said to be consistent. Here. On the other hand, if there is no solution, then it is said to be inconsistent. This system is said to be inconsistent system of linear equations. If what I am saying, there is no solution. If there is no solution, this is important here. No solution. There is no solution. If there is no solution, then the system is said to be inconsistent system of linear equations. Okay. See students, now let us have a look at the geometrical representation of this linear equations in two variables. See, we have three possibilities there. So what are those three possibilities? If you take into consideration, that is a first possibility. Possibility 1. See, what is the first possibility? See, this is your x-axis and this is the y-axis. If you plot the graph of these two equations, one is say a1x plus b1y plus c1 is equal to 0. This is one of the linear equation and its graphical representation. You have studied already in 9th standard. A linear equation in two variable is always a straight line. It is a straight line. You will get a straight line graph. Somewhere else it may cross here, no problem, but anyhow you will get a straight line graph here. See, another equation, another linear equation, if you plot here, the equation may come in this manner. Okay, that is this one I would like to take it as a2x plus b2y plus c2 is equal to 0. See what is happening, these two are intersecting at a common point. So this is common, so this common point, say this as a p which is alpha comma beta. So x is equal to alpha and y is equal to beta, which is common here for both the equations. So this is one situation. So there exists only one common point with respect to these two lines. So there exists how many solutions? There is only one solution. There is only one solution. So in this case, there exists only one solution, or you can say the solution is unique. It has, or this system has unique solution. So when they intersect, this is what our observation. The second point to be considered here is, here as I explained already, if the system has at least one solution, that system is said to be consistent. In this case, it has unique solution, definitely one solution. So this system is said to be consistent. The system is said to be consistent. One more very important link I would like to give you. If you observe the coefficients of x, y, z in such a situation, those equations which intersect, if we study, if we analyze practically based on calculations, what we confirm, the relation between the coefficients, see, a1 by a2, a1 upon a2 seems to be not equal to b1 by b2 in this case. a1 by a2 is not equal to b1 by b2. This condition you remember for this. a1 by a2 is not equal to b1 by b2. So when the two lines intersect, algebraic relation is a1 by a2 is not equal to b1 by b2. This condition you have to remember. So this is case number 1 or possibility number 1. Now what is the possibility number 2? Second possibility. What is that? Possibility 2. If you plot the graph of the given two simultaneous linear equations in x and y, then here there may be, here this is one line, say this as a1x plus b1y plus c1 is equal to 0, and the chance is, the possibility is, for the second line, whatever the coordinates you are going to find out, they coincide with the first one, and here the line coincides. On plotting the points, joining them, it coincides with this. So this is a2x plus b2y plus c2 is equal to 0. This is second possibility. That is, the two lines coincide on one another. Geometrically, the two lines coincide on one another. So when they coincide, every point on the line is common to both the equations. So every point satisfies both the equations. So every point becomes the solution. So how many points are there on this line? We can identify infinite, countless, endless number of points on the number line, or simply this line here. So that's why what we can say, there is no only one solution as in the previous case. There are many solutions. The solution is, there is infinite solution. Or you can say many solutions. Number of solutions is not finite here. This is one thing. And whether it is consistent or not consistent, what is your opinion? When do we say that it is consistent? At least there should exist one solution. But in this case, many solutions are there. So why you are hesitating? Why will get confused? Definitely it is going to form what? The consistent system of linear equation. It is going to form what here? The consistent system of linear equation. And what about the geometrical condition? Algebraic behavior. How the coefficients behave, how the coefficients relate. If you observe based on calculations, based on this type of equations, it is found that a1 by a2 is equal to b1 by b2, and this is also equal to c1 by c2. So this is what the algebraic criteria for the second case, that is possibility number 2. The two lines coincide on one another. Next, what is the last possibility? There is one more possibility, that is what? Possibility 3 I would like to take, or case 3. Here the theme is in this manner. This is your x-axis, this is your y-axis, and this is the graph of the first equation, that is what? a1x plus b1y plus c1 equal to 0. And the chance in this case is another graph is in this manner. See, if this is a2x plus b2y plus c2 is equal to 0. If you plot the graph, this may appear, definitely out of 3 one situation should come. See, if we extend on both the sides, they never meet. So when they never meet, such lines are considered to be what kind of lines? Parallel lines. So parallel here, in this case they are parallel here. So when the two lines are parallel, then what we can say, here there is no any common point in between these two lines. If there is no common point in between the two lines, means there is no solution at all. Okay, so what we can say, no solution. In this case there is no solution for this set. Okay, there is no solution here. And when there is no solution, the system is said to be inconsistent. The system is said to be inconsistent here. And what about the geometrical condition? The geometrical condition is a1 by a2 is equal to b1 by b2, but this is not equal to c1 by c2. a1 by a2 is equating with b1 by b2, but it is not, both are not equating to c1 by c2. So this is what the observation when the two lines are parallel here. So geometrically, if you plot the graph of the simultaneous linear equations, in the first case, here in this case, they intersect. Here they may intersect. So when this situation comes, a1 by a2 equal to b1 by b2, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Here in this case, they coincide. They may intersect, they may be coincide, they may be parallel. Here this is what? The third chance, parallel. And the algebraic condition is a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. So this is what the one part of the theory of this topic. And further it comes to discuss the different ways of solving the simultaneous equations. That I will take into the next video. See students, in my leisure time, whenever I will be free, I am trying to make some concept videos and some videos based on the problems, both for Kannada medium and English medium. And if you like my way of teaching, if the mathematics subject reaches you, please subscribe my channel, that is Excel in Mathematics with Kotre sir. And please put your comments. Please like, if you really like, then click on the like button, and you please inform what is your need, so that I can prepare the videos based on your need. So your feedback, your interaction is very important for me. Okay, can you do so? I think. Okay, bye. See you in the next video.